Hey everyone, it's us from Diploma in Microbiology. Today we are going to be talking about volumetric analysis in environmental monitoring. Volumetric analysis, also known as sterimetric analysis, is an analytical technique that involves measurement of volume from a solution with known concentration, which is used to determine the concentration of the analyte. One of the common volumetric analysis is titration. Titration is a common practice of volumetric analysis. These are some common terms related to the topic, which is titrant, a reagent solution with precisely known concentration that is added to the analyte. Analyte, the chemical substance in the sample whose concentration is unknown and being measured, and titrate, the actual volume of titrant dispensed from the burette to reach the equivalence point. Now we will proceed with how volumetric analysis can be used for water treatment. So why volumetric analysis is used for water treatment? Is to test the pH of water to be commercially used. Contaminated water are below 6.5 pH or higher than 8.5 pH, when it was supposed to be 6.5 pH to 8.5 pH, which is neutral. Another reason is to preserve the natural rivers and lakes, which is important to guarantee a cleaner environment for wildlife.
Next is theory. In volumetric analysis and environmental monitoring, the most and the key method is the titration method. Titration is a vital analytical technique used to determine the exact concentration of a specific substances in a sample. In environmental monitoring, scientists use it to measure pollutants in air, water, and soil, used to track contamination process and ensure compliance with environmental regulation. For instance, acid-base titration is used to monitor the pH and acidity of rainwater, which is critical for tracking the impact of acid rain on local ecosystem. By titrating the rainwater samples against a standard base, environmental scientists can calculate the exact concentration of hydrogen ion present in the rainwater. This allows them to measure how acidic the rainwater actually is and ensure it's suitable with environmental safety regulation before it damages the soil, forest, and aquatic life.
So now I will explain about the procedure and the method used in the titration process. First of all, sample collection. The samples are collected from the nearby river or the rainwater itself. It will then be used in the titration process. Second, preparation of reagent. The standard solution of titrant is prepared. Usually, strong acids such as hydrochloric acid or strong base such as sodium hydroxide, depending on the analyte that is measured. Then, an indicator such as phenolphthalein or methyl orange is used based on the pH level range. Third, acid-base titration. The sample then will be titrated against the standard titrant solution. If the sample is acidic, it will be titrated against strong base. If the sample is alkaline, strong acid will be used. The titration is done until a color change is observed, indicating the equivalence point. Now I will explain the titration procedure. First, a known volume of sample is added into the conical flask. Second, indicator is added into the same conical flask. Third, titrant acid or base is added into the conical flask from the burette. Swirl the conical flask while adding the titrant. Lastly, when the color change is observed, stop titrating immediately and measure the volume of titrant used. After the titration curve graph where pH versus volume of titrant used will be plotted. This curve helps finding out the sharp pH change near equivalence point. Lastly, the concentration of acid or base in the water sample will be calculated. This calculation is needed to adjust the pH level, aligning it with the regulatory standard, ensuring the water is safe to consume and use by people.
This slide shows an example of results that obtained from environmental water quality monitoring. The table presents several important parameters, including pH, electrical conductivity or EC, chloride, iron, manganese, copper, zinc, cadmium, and nickel. These parameters are commonly used to evaluate the quality and safety of water. Next, let's look at the titration results table. 3 titration trials were carried out to improve the accuracy of the experiment. The titrate values obtained were 24.5 ml, 24.7 ml, and 24.6 ml. Since the values are very close to each other, this indicates that the experiment was conducted consistently and the results are reliable. The average titrate value obtained was 24.6 ml. Using this average titrate value, together with the concentration of sodium hydroxide, which was 0.1 moles, and the sample volume of 25 ml, the pH of the river water was calculated. The calculated pH value was 6.8. As we know, a pH value below 7 indicates acidic condition, while a pH value above 7 indicates alkaline condition. Therefore, this river water sample is considered slightly acidic. However, according to Big Recommend pH range for natural water, which is between 6.5 and 8.5, the pH value of 6.8 is still within the acceptable range. Therefore, the water quality can be classified as acceptable and suitable for environmental monitoring purpose.
So in conclusion, volumetric analysis are indeed important in environmental monitoring, as it helps to identify the contamination in groundwater and monitor the overall water quality. This allows water to be much safer to use in daily life. The nature also benefited from this by making the river or ocean water less polluted and purer for wildlife animals to drink. It too should be credited that volumetric analysis has contributed to more depth into chemistry in general, as we learn on how to identify the contaminants, the pH level, and determining the safe amount of ions in water for daily consumption. So that's it for today. We're glad you watched till the end. Please like and comment, tell us what you think. We will see you next time. Bye.